So let's talk about ionic bonding. And in particular, when you cool it down to, I don't know, like 1,000 degrees and it's still a solid. So we're going to talk about ionic lattices. Now, it's really important that you remember metal ions are really large and only hold on to, or metal atoms, sorry, they're quite large and they only hold on to the outer shell electrons or valence electrons fairly weakly. Non-metal atoms, on the other hand, they're fairly small, so they hold on to them really tight because it's close to that positive nucleus. So you just cram in there. This means metals lose electrons to satisfy their octet rule. Non-metals, on the other hand, they gain electrons to satisfy their octet rule. So this transfer of electrons results in charged ions. For example, over here we have a neutral sodium atom and a neutral chlorine atom. When they form an ionic bond, this valence electron here leaves, chuffs on over here, and you have more electrons than you do protons in a chlorine, so it gets a negative charge. You have less electrons than you do protons here, so you get a positive charge. There's now a large electrostatic charge between these two. It's very, very strong. The electrostatic charge between these two is super duper strong, and they bond together. When they're a solid, they clump together in very specific shapes called lattices. And it's, as I said, it's their opposing electrostatic charge which holds them together, and that's super strong. Due to the very large number of each element in an ionic salt, so a solid, we need to use an empirical formula, which is just the simplest whole number ratio. Otherwise, it would be Na 1 times 10 to the, I don't know, 200, Cl 1 times 10 to the 200. But you see those numbers are the same, so we can just simple it down to NaCl. The ionic lattice, let's have a look at it. The properties are that it is hard and it has a high melting point. And this is because there are strong bonds between the atoms, really strong. It's insulated when it's solid. There's no free electrons to move around. However, when it's molten or dissolved, there are free ions that move, which allow it to conduct electricity. And this is why salt water conducts electricity. It has a repeating structure, and this is the need for the empirical formula. Alright, I hope that made a lot of sense. If it didn't, feel free to ask any questions in the comments below, and we'll get back to you as quick as we can. Thanks for watching. Bye now.